And today we're going to be talking about transfer of thermal energy. Conduction, convection, radiation. I'll start with a very basic introduction to the three of them. Conduction mostly happens from solids, so solids to solids, solids to liquid, solid to gas. If it has a solid involved, it's conduction. So transfer of thermal energy in solid is conduction. Transfer of thermal energy in a fluid, whether liquid or a gas, is convection, and we're going to explain it further. And radiation is the transfer of thermal energy through medium or vacuum, but it has to come from a source of heat. Here's an experiment where we're testing conduction. We put four different rods with solid wax on them. Obviously, the one that will melt the solid wax the fastest due to the heat of the boiling water passing through is the best conductor. Here's another example. If I got three different beakers, one with no insulation, one insulated with cardboard, and the third insulated with a bubble wrap. The one with no insulation will drop its temperature the fastest, cardboard less, and the insulated bubble wrap will be the least temperature lost. How convection works. It's as simple as the particles that are closest to the heat. They will gain kinetic energy. So they will expand. And as they expand, they will become less dense, and therefore they will float. On the other hand, particles that are up, they are cooler, so they have less kinetic energy. They are more dense, so they will sink. Here's an example. A beaker of water is placed on a tripod and heated from below using a Bunsen burner. After some time, the water at the top becomes warm, even though only the bottom is directly heated. Explain how the water becomes evenly heated using convection. Water at the bottom of the beaker gains heat energy. Particles move faster. So it expands, becomes less dense, and therefore rises. The cooler, denser water sinks to take its place. This is known as convection current, which is basically continuation of the circulation of water. Eventually, the thermal energy is distributed throughout the beaker, making the whole volume warm. So why convection occurs? When part of the fluid, which is the liquid or gas, is heated, kinetic energy causes particles to move faster, making them expand, making them less dense, going up. And the cooler ones, they are more dense, so they sink down, and this movement is known as convection current. I've put a couple of examples just to repeat. So let's move on to the questions themselves. In winter, a person places a small electric heater on the floor of a cold room. After some time, the upper part of the room becomes noticeably warmer than the lower part. So the upper part is warmer than the lower part. Explain this observation. The air near the heater gains thermal energy, so particles move faster. The heated air expands, becomes less dense, and goes up. The cooler, dense air near the ceiling sinks down. By convection current. As a result, the top part of the room becomes warmer first, while the bottom remains cooler until full circulation of heat happens. Now that we've spoken about conduction and convection, let's go a bit into radiation. Radiation is part of the electromagnetic spectrum, which we get from the sun. So as this thermal energy comes from the sun to Earth, it travels through so many things. First, it goes through space, which is vacuum. And then it reaches our atmosphere, which is a gas. And then if you're underwater, heat will still reach you, so it can go through a liquid. And if you're wearing any clothes, the heat passes through it, so it can pass through a solid. So radiation can travel through vacuum, solid, liquid, and gas. Okay? Now let's look at the effect of surface color and texture or infrared radiation. Black and dull colors are very good absorbers of heat and very good emitters of heat. So in winter and in summer, we should wear black or white? We should wear white, because white is a poor absorber, poor emitter, and good reflector. So imagine in summer, the weather outside is very, very hot. So if you're wearing white, you're reflecting the heat, so nothing will heat you up even more. In winter, your body is warmer than the temperature outside. So you want this heat to be stored inside your body. You don't want it to come out. So if we wear white, we don't allow the heat to be emitted outside. So white is a perfect color for summer and winter. Black is just like allowing heat to go in and out easily. So it's a very good absorber, very good emitter, and it's a very poor reflector. That's why a black car gets hotter in sunlight than a white car, and radiators are often painted black to emit more heat, and space blankets should be shiny foil to reflect body heat back to the person. Example: a thermal imaging camera is used to view a room. It shows warm objects like people, laptops, and lamps glowing brightly, while colder objects like walls and books appear darker. Why? Because all objects emit infrared radiation, even if they're not visibly hot. Warm objects emit more infrared radiation than cooler ones, which the camera detects, and this proves that all objects emit thermal radiation and hotter objects emit more of it. Conclusion: thermal radiation is emitted by all objects depending on their temperature. Another example: two metal plates of the same size and material are heated at the same temperature. One plate is painted dull black, other is shiny silver. After they're removed from the heat source and placed in a cold room, the temperature of the black plate drops faster than the silver plate. As we said, that the black matte surface are good emitters, while shiny reflective surface are poor emitters. So even though both plates started at the same temperature, the black surface radiates energy away more quickly due to its surface texture and color. So conclusion: surface color and texture affect how quickly objects emit and absorb thermal radiation. Dull black surfaces emit and absorb more, shiny white surfaces emit and absorb less. Here's another experiment for radiation, which basically what they do is that they have different kinds of colors and textures, and they just measure the amount of infrared intensity. As we can see, matte and black had the highest, and shiny and silver had the lowest. Okay. Let's move on. One second. Okay. This is the same thing, same experiment. Here's a cooling curve. As we can see again, that no matter what temperature I started with, the shiny white one is the one that will lose the least thermal energy, and the matte and black will lose the most energy. Example: a lovely cube is filled with boiling water. Each of its 4 vertical faces has a different surface: black matte, white matte, shiny metal, dull gray. Infrared detector is used to measure the radiation emitted by each face. Which surface will show the highest radiation reading? What do you think? Which one will show the highest radiation reading? Of course, it's the black matte. Why? Because it's the best emitter of infrared radiation, so it will easily allow the heat to go through easily, while the shiny ones and the white surfaces will just reflect and emit less. So the correct answer is the black matte. Okay, let's see if we have any more examples that we can go through. Okay, again. Another example: 2 identical metal cans are placed an equal distance from a strong infrared heat lamp. One can is painted black and dull, other is shiny and silver. Thermometers are inside both to measure temperature over time. What result is expected? Of course, the black dull surface will absorb more infrared radiation than a shiny silver surface. Therefore, it heats up faster under the same energy period. So the correct answer is C. So what are the consequences of thermal energy transfer? First of all, heating objects such as kitchen pans process involve conduction. So if I have a metal pan on a stove, heat is transferred from the burner to the base of the pan by conduction, right? And then since metals are good conductors, they transfer the heat fast. So they heat up whatever food or liquid is inside the pot. But the consequences is that the pan heats up quickly and cooks food efficiently, but the handles, if also metals, can become very, very hot and can cause burns. This example comes a lot as a question. Using an electric or gas heater placed on the floor of a cold room, obviously the heater warms the air near the heater, so it will go, the air warm will become less dense and will go up. And the cooler air, which is more dense, will sink, coming down. So this is absolutely fine, but the thing is that with time, the room becomes cooler at the bottom and warmer only at the top. And that's why in such places they usually put ceiling fans to make the warm air get distributed all over the room. Here's the third example, fire burning wood or coal. Here we have conduction, convection, and radiation. Radiation, of course, because it's coming from the fire. Conduction, because of the wooden piece that he's holding, which is a solid. And we said anytime it's transferred by direct contact from a solid, it's conduction. And convection, as the heat is transferred to the air, which is a fluid. And we said with fluids, it's convection. That's all for today. Please let me know if you have any questions. Have a lovely day.